All right, now on part 2 of these circles, conic sections notes, we have some examples that are in general form where all of our variables and constant is on one side of the equation and equal to 0 on the other. This is called the general form of a conic. You're used to also calling this like normal form. You've heard that before in the past, but this is called the general form of a conic section. And so we need to get this into the standard form of a circle. We notice that we have a middle term. There's an x term, not only an x squared, but an x term, and also a middle or y term for the y squared. So we're going to have to complete the square on both x and y. So in order to set that up, and these are some of the notes that you can put on your side margin. This is something you can do. You can gather the x's together, gather the y's next to each other. Okay, you can move the constant to the other side of the equation. You're going to complete the square anytime you have a middle term, and in this case we have to do it twice. Sometimes we won't have to for one of them, or maybe for both of them. And we would have to write the standard form and then identify h, k, and r. So we're going to go ahead and get started with that, just moving the constant over. We put the x next to the x squared, we put the y next to the y squared, and this part right here is just setting up for completing the square. I want to encourage you to actually draw in plus and a blank line, and over here plus and a blank line. Do it also for the y's over here, plus blank line, plus blank line. The reason is, remember, every time you add something to an equation, if you don't add it to both sides, you are no longer having an equivalent equation. So you've got to remember that. And when you see these blank lines, if you forget to add it to the other side, you're going to be looking at that going, what is that? Why is that there? Something's missing. Oh yes, I got to remember to add it to both sides. So if you would just simply draw this in, plus blank and plus blank, trust me, it'll help you to avoid forgetting that. So completing the square on x. What is 6x cut in half? What's 6 cut in half? 3. What's 3 squared? 9. So we're adding 9 over here, and I'm just showing you what I'm doing here. So we're adding 9 to this side. We're also adding 9 over here. Write it down right away so we don't forget. What's half of negative 2? And then we're going to square that. Half of negative 2 is negative 1. Negative 1 squared is plus 1. So these are always going to be a positive number in here because we're squaring them. So we're adding 1 to the other side also. And now cleaning that up, we're going to come over here, and when you factor this, it will be the square of the same exact binomial because this is now a perfect square trinomial, and so is this one. So when you factor this over here, you get x plus 3 quantity squared. When you factor this over here, you get y minus 1 quantity squared. Okay? So again, it's really easy to know what these are because half of 6 was 3, half of negative 2 was negative 1, and there you go. Now you have the equation of that circle. What's its center? What makes that 0? Negative 3. What makes this 0 over here? Positive 1. So there's your x coordinate. That would give you your y coordinate. And r would be the positive square root of 36, so 6. So now you have this information. Again, you can pause the video if you need to write down some more. Maybe I went through this pretty quickly, so you can write down that stuff over there on your side margin. And you can go ahead and graph your circle on the graph. So again, pause the video if you need to. Here's what your graph should look like. Negative 3, 1. Again, remember to correctly get your points centered and go the correct distance for your radius. Moving along to number 6 now. Again, we've got a general form here, and we need to rewrite this in the standard form of an equation for a circle. So once again, I notice we've got an x term and we've got a y term. So we're going to have to complete the square on x, and we're going to have to complete the square on y. So to get started, we'll move the constant over and move these next to each other. Move the x with the x squared, move the y with the y squared, move the constant over. Now set it up just by splitting things apart. I don't really need parentheses here again, but I do it just to say, hey, I'm focusing in on this over here for my x's. I'm going to focus separately on those for my y's. And I remember to put my plus blank so I can remember when I add something that completes the square for x, I better add it to both sides. And when I find that value that completes the square for y, I'm going to add it to both sides also. So again, you should be very familiar with completing the square method on quadratics. Shouldn't have to go too far with this or spend too much time on that. What's half of negative 14? Negative 7. What's negative 7 squared? 49. So 49 is added to both sides. What's half of 4? 2. What's 2 squared? 4. So adding 4 to both sides. Once again, now that you're at this step, you're ready to combine all those on the right side for your radius. You're ready to factor each one of these. They're perfect square trinomials. They're going to be the square of the same binomial. So this was x minus 7 squared. This one was x plus 2, or sorry, y plus 2 squared. Okay? So again, if you need to keep practicing completing the square, there's numerous videos, or sorry, numerous problems that you should be able to do on Khan Academy if you need to keep working on those. But hopefully you are brushed up on that and just buzzing through those. What is the center of this circle? You should have 7, negative 2, and a radius. Positive square root of 64 is 8. So graphing that, 7, negative 2 is your center. Go up, down, left, and right. Obviously, this one's going to go off our graph. Don't worry about it. Just deal with it. Graph your circle. What else do we have? We have 7 and 8. And these are like the last problems from our last set of notes when we were dealing with parabolas. This time, we're going to be asked to write the equation of a circle, given some information. So in example 7, it says to write the equation of a circle with the center at 2, negative 1 and radius 5 square root of 6. This is really nice because they've already given us the center and they've given us the radius. Okay? So all we have to do is plug in h and k. We know this is h, we know that's k. We know the radius. But we got to remember we got to square this for our equation over here. So plugging in 2 for here and negative 1 over here would give us this value right here. It's going to be x minus 2 quantity squared plus the quantity of y plus 1 squared. And that's equal to 150 because this is 5 times 5 and square root of 6 times square root of 6 is just 6. So 25 times 6, 150. And there you have it. Last example, write the equation of a circle with the center negative 3, 8. But now they're not telling us the radius, but they're giving us another point. And you should be able to figure this out because every point that's on the circle, if you plug it into the equation, it has to be true, does it not? Equations are point testers. So if you were to plug this in for x and this in for y into the equation of the circle, we should be able to figure out what the radius is. Okay? So for right now, we know we need to build up this equation. We have h and we have k, so we can start with that. Plugging in negative 3, so x minus negative 3 gives us x plus 3. Y minus 8, there we have it. So we have to use this information again. So write yourself that this is x and this is y. We're going to plug this in for x. We're going to plug this in for y. We're going to figure out what that is. So that's what I was saying over here. These are things you can write in your side margin. So 5 squared plus negative 7 squared. So we've got 25 and 49, and that gives us 74. Now, if we were graphing this, I would need to know what that square root is. But I'm not asking you to graph it. I'm just asking you to write the equation of the circle. And the equation uses r squared. So if you take the square root of that, don't. Go back. This is the only thing we needed to find now. So we're going to take this and go back up here and erase. We're going to go to this part right here. We're going to take out that r squared and put 74. So this is the equation of our circle. Quantity x plus 3 squared plus the quantity y minus 8 squared equals 74. So then I'm not asking you to graph it, but what if I did? What would be its center? Negative 3, 8. What would be its radius? positive square root of 74, and you would see if you could reduce that down into reduced radical form. Not exactly sure that has any perfect square factors. But what would you do to estimate its radius? What two perfect squares are that in between? 64 and 81, so somewhere between 8 and 9 units away. Not exactly 9, but greater than 8 units away from that center, if you were graphing it. And let's see. Is that our last example? So how would you say parabolas are different from circles? How would their equations differ? So as we're going through this chapter and thinking about the different conic sections, I want you to keep thinking about that. How are they similar? How are they different? Because all of these conic sections do have similarities and then some, what makes them their own unique conic section, their own equation. So if you were thinking about circles and parabolas and their equations, you know that the circle has both an x squared and a y squared. Parabolas, only one of those could be squared. If both were squared, it wouldn't be a parabola. Circles have centers and parabolas have vertexes, right? Have a vertex, can only be one. The parabola, but again, we're talking about the equation of them. So that's how they are different from each other. See you next time.